Welcome to this episode of Microchips. In this episode we have a look at some more PCBs that I have bought from JLC PCB. I bought these and they're not on the promotion or anything, just to let you know. Anyway, here we have the PCBs. So we have two sets of PCBs this time. We have these nice purple ones, because I wanted to try the purple finish on them. They're the purple solder mask, and they look very nice. And the main PCBs here are another revision of my Arduino LC7137 modification, and hopefully this is the final revision of it. So as always, they look pretty damn good. Let's have a closer look. So you can see there's a couple of through hole components and a couple of diodes as well. Now, as you can see, we have a lock light as well, and in the bottom of the screen there you can see the prototyping that I used for the lock circuitry. It was inspired off another board, so I just wanted to make sure that it actually worked, which it did in the prototype, so it should work on this. Now this board I'm going to be using as a frequency compensation board. So basically it's just switching in a capacitor on one of the bands. So the circuit was taken out of the Midnight Express 2 book in the Uniden modification part and into EasyEDA, and that's the EasyEDA drawing of it, very similar. And there's the EasyEDA circuit board. Now this circuitry looks very similar to the circuitry that was on the old Tonks boards, which you can see here. We have a capacitor on the collector, there, 1K 10 nan, 1K 10 nan, and a 10K off the emitter. We have a 10K off the emitter somewhere. Yep, 10K off the emitter. So yeah, it looks very similar. So I think that's where they may have got the idea from for this frequency compensation. But I've not used static capacitors, or I've not got the crystal on board on mine. This is just going to be a wire straight to the board, straight to the main board and straight to the crystal. And instead of having a fixed capacitor, I'm playing around with a variable capacitor, and this seemed to work in the prototype. So here's all the pieces that we're going to be using to construct the board. Now we'll do construction in another video, but by the power of editing, there it is put together. As you can see, very similar to the boards that I've already got. I've not bothered cleaning any flux off this time. I just wanted to get it on and get it working. And the frequency compensation board, I could have done it with SMD components, but for me this is the smallest I could make it with through hole components, and it is pretty tiny, as you can see by the centimetre squares on the back. So in this video we're going to be looking at the PLL modification board. So we'll jump straight in. We've got it in one of my Harrier CBXs. We've got the voltmeter on the VCO, and we've got the frequency counter on the output. And as you can see, the frequency is just a little bit low on this, but that's to be expected. We've not fitted the frequency compensation board to this, we're just doing a test of the PLL mod board. So we're down just a little bit on UK40, which is fine. That can easily be adjusted out. Jump onto midband, slightly down on midband, should be 26965, and that was 26964, which is fine. And 27404 should be 27405, You can see VCO voltages within specification. Now the main difference to this board was I wanted a lock indicator for the VCO, so what we're going to do now is we're going to take the VCO out of lock, and you should see the lock indicator go out, which it does. There we go, it's dropped out, and we'll bring the VCO back up again and it comes back into lock, so that works nicely. Plus we've also added another transistor in there as well, which is to mute the mid-band signals when on UKFM. This was another part of the other board as well. Just one transistor and a couple of resistors. It stops noises on Amstrads, I believe. I've not had a chance to test it in an Amstrad, but that's why that transistor's there, to stop noise from the signal going into the audio circuitry. But apart from that, this is working beautifully. So what's next for this project? Well, there is no next for this project because this is where I wanted to be with this project. I've made a board with an Arduino, 2 PLLs, we've got the lock indicator, we've got the noise suppression transistor in there. Alright, we've not got the frequency compensating components in there, but we've made another board for that, and that can be fitted after. So that's it for the Arduino project. So what's next for this project? Well, it's a PIC chip based version of this. Now I've already started work on this, I've already prototyped it, as you will have seen in a previous video, and everything works just nicely on the prototype. So I was waiting for this board to arrive so I could check the lock circuitry, and I will then transplant the PIC chip into the board instead of the Arduino. But all in all, very happy with how this has turned out. Now if anybody wants any of these boards, I do have some spare. I have the other version of the board without the lock indicators, and I've got this version of the board with the lock indicators. They are in limited supply, so if you're interested, drop me a line. The email's in the about section of the page, and we'll see what we can do. But that's it for the Arduino based version of this project. It's turned out very good. It's as small as it can be. It's got some of the useful components of the other boards. I've also added the resistors to protect the wires going to the switch. Should they ever get touched to earth, it won't blow the PLL up. So basically it's a 2022 remake of a 1980s modification board, which very happy with. It's turned out good. So stay tuned for the PIC version of this board, which is coming very soon. Anyway, I hope you enjoyed the video. Please like, subscribe. If you want, you can Patreon. And thanks for watching, and we'll see you in the next video.